myself D.R.Sonawane, faculty in Physics Defense Career Academy. I hope you have seen the previous video that is related with the law of radioactive decay. So today we will see the format, or we can say form of the radioactive law in the form of equation, as well as we will see the half-life of radioactive element. So let's see the form of radioactive decay law. As we know that there is a definition, rate of change of disintegration of nucleus is directly proportional to the number of nucleus unchanged. That equation is dN by dt is proportional to n. By putting here constant lambda, the equation becomes lambda n dN by dt. We put here negative sign because as there is a disintegration of the nucleus in radioactive elements, there is decreasing remaining nuclei. So negative sign indicates that the n value of n is decreasing. So by forming this equation in different form, we will take a derivative by keeping this n here, dN by n is equals to minus lambda dt. By integrating both sides, here time is starts from 0 to t, and number of nucleus, the original number of nucleus is n0, and the remaining nucleus at any time, at any instant of time is n. So here is the format of 1 by n dn. We can write it as a log of n, where limit is what? n0 to n. Then here integration of minus lambda dt is minus lambda into t. So this becomes the equation. By putting the value of n and n0, we get log n minus log n0 minus lambda t. So log a minus log b is nothing but the log a by b. By the equation, we can write it as a log n upon n0 by the formula of log a minus log b, and here minus lambda t. If we take this log to right hand side, then we will get n equals n upon n0 is equals to e to the power minus lambda t. Log on that side becomes exponential form of minus lambda t. So number of nucleus remaining is nothing but the number of nucleus at initial stage into e to the power minus lambda t. Means time is varying exponentially and the number of nucleus. So for plotting the graph, this equation is very important. By this equation we can find out the half-life of the radioactive element. So for half-life of the radioactive element, half-life is denoted by T half. If we put T half instead of small t, we know that at this time the number of nucleus becomes half of the original. Number of original nucleus is n0, and the half of the original nucleus is nothing but the n. So half-life of any radioactive element, it means when the half of the original nucleus is disintegrated, that time of the radioactive element is nothing but the half-life of the radioactive element, means n0 by 2. By putting value of small t is equals to t half and n equals to n0 by 2, we will get this equation right as n0 by 2 is equals to n0 e to the power minus lambda t half. Right? So n0 get cancelled. The equation becomes, if we take reciprocal of this equation, we will get 2 equals to the minus lambda t half is becomes plus lambda t half. So e to the power lambda t half. By taking this e exponential form to this left hand side, the 2 becomes log 2 here, log 2, and here is lambda t half. And value of log 2, if base is E, then this value becomes 0.693. This value becomes 0.693. By dividing it by lambda, we will get half life of the radioactive element. It means what? Lambda is nothing but the disintegration constant. For every element it is different. For uranium it is different. For thorium it is different. So according to the value of lambda, which is constant for a different element, the half life is calculated. It means 0.693 means what? 69.3% of the nucleus is disintegrated at that time. Mathematically, for 150 percentage is 50, but in radioactive element, for half life of the radioactive element, 69.3% nucleus are already disintegrated. So if lambda is constant, we can say that the half life of the radioactive element is nothing but the when 69.3% of the nucleus from the original nucleus are disintegrated, then the time is known as half life of the radioactive element. I hope this equation and this theory will be benefited in competitive examination. So this is enough for now. Thank you. Have a nice day.